Hello, hello. Welcome to this week's video. This week is going to be all about how to pull your survey data from SurveyMonkey and put it into an Excel spreadsheet so that you know how to work with it, and how to work with that Excel spreadsheet, making it cleaner, easy to use, how to sort it, and how to do some manual coding in order to get your data ready for running some statistical tests. All right, so step number one, we need to pull our data from SurveyMonkey. So I'm going to go into my internet browser. I'm going to go on SurveyMonkey's website. I'll show you starting from my dashboard. So when you log in, this is your dashboard. It shows you all your surveys that you've created on your account. Today, I'm interested in pulling the data from this example survey 1, eating and spending. I'm going to click on my survey. It'll load and it'll show me the specific survey information, right? How many responses I got, whether the survey is still open, things like that. If you're set with collecting responses, you're all done, you should make sure to close your survey status. So under collections, I can click web link 1, right? This was the link that I was using to obtain my responses. I can go over here where it says open and hit close collector. So this will give you a notification, right? Once you click close, people can't access or take the survey, right? Nobody can submit responses. And it only works for this specific link. So if you had multiple links going or different versions of how to collect responses, you're going to have to close each one of those, okay? And then it'll give you a little message. This is what people going to your link will see instead of seeing the first survey question. So I'm going to go ahead and close the collector. That way no more responses can come in. All right, in order to pull my data, I'm going to go into the Analyze Results tab over here. It'll just take a minute to load, and you'll see some general response information. This is sometimes helpful, but we know how to do it in Excel, so let's do it the good old-fashioned way. All right, on the left-hand side, there's going to be a few little buttons over here, one of which is a downward-facing arrow that when you hover over it, it'll say Exports. Go ahead and click on that. For you guys, likely there'll be nothing in the export column because you've probably never exported the data before. Here it'll show some historical exports that I've already done for this survey. I'm going to click New Export. Under the Export drop-down, it'll give me 3 options: Summary Data, Responses Data, or Individual Responses. You must select Individual Responses. This will show you every person's answer for every single question. If you were to select one of these other options, it wouldn't give you the full data set, it would give you partial data. That's pretty useless when running statistical tests in Excel. So make sure you select this last option, all individual responses. When you do that, you'll get a pop-up screen. Notice you'll be in the All Responses Data section here. The first option is what file format you want. XLS is the version supported by Excel, right? It opens in Microsoft Excel. That's what we want. Current view works for us. Columns condensed also is good. What does matter is your cell formatting. You can select either actual answer text, which is useful as a reference, or numerical value. This will be what you really need to run your data. So make sure to select numerical value. I'll show you what that looks like versus the actual answer text in just 1 minute. But select the numerical value for now. And then give your file a nice little name. I'm going to call it, this is the data set, right? This is the data set I want to use. And hit export. It will create, first the website will kind of process the request, so you'll stare at a blank screen for a little bit, and then you'll get a notification saying your export's ready for download. So go ahead and click the download button. That file will then go into your download manager or wherever files from your browser go when you download them. Please note, it does go in a zip file or a zip folder. If you have like integrated unzipping software like I do, I can just click the folder and it'll pull up the file here. You may need to go manually into the folder, authorize it to be unzipped, and then collect the files. You can Google how to unzip folders if you're having a problem with that. Okay, So I'm in this is the data set zip that I created, and here is my Excel. So I open up the Excel, and it looks a little something like this. It's a little messy. There's lots of garbage. We look over here, and then there's kind of more data that we're familiar with over on the right-hand side. So let me show you the reason why we selected numerical data versus the first option, which was actual data answers in column. If I were to have selected the first option, instead of giving me a number for my categorical variables, it would have showed me in words what each respondent selected. This is useful as a reference point. It's easy to read. It's pretty, you can navigate it a little bit simply. But remember that Excel isn't smart enough to process words. It really can only process numbers. And that's why we need to give it the numerical values. That way Excel knows how to sort it and deal with it. Okay, so that's why we choose this option, the numerical option. All right, I can delete that word, survey. Okay, so what do I need to do once I have my data collected? Well, I recommend that you pull your data and you complete what I call cleaning up your data first. So you're going to make it nice and neat and get it into a format that then can be a starting or a reference point from for all future data workings. So let me show you what I mean by cleaning up the data. So over here on the left, SurveyMonkey gives you information that you really don't need, like an identification number for each respondent, the survey ID number that it was collected on, even things like the start and the end date of when the participant completed the survey. I really don't care about that. It's interesting, but we don't care, right? The other thing that it gives us is the respondent's IP address, if you allowed SurveyMonkey to collect that. So IP addresses are considered identifiable, so please delete this information as soon as possible. We don't need it. We don't want to be able to reference data back to the respondents individually. So all of these columns that are totally useless to me, I'm going to highlight and I'm going to delete them. Get rid of all the stuff we don't need. We want a clean data set. Okay. So then we're left with questions and information that actually we care about, right? So this first column, you can see the actual question that was asked in the survey. So A1 here is the question, what is your gender? A2 tells us what type of question it was. It was like a multi-choice response versus an open-ended, right, where somebody could type something in. So it was a response, and people selected, ones or twos, what's their gender. Here's a point where I like to have a reference point. So when I'm working with my data, I like to know what in the world does a 1 mean versus a 2, what does a 5 versus, a 3 mean for this one. So what I do is I like to have a printed copy of my survey available to me and, sitting on my desk when I'm working with data. If you have access to a printer, go ahead and do it this way. You can jot down notes, or you can keep some sort of like Google Doc as a cheat sheet. This is your code book. What does each question ask, and what were the options that were given and their numerical equivalents, right? So for gender, let me annotate this here. So if I were to print this out, right, I would print it, and then I would jot with a pencil what each option was. So female, because it was the first option I gave my participants, is always going to correspond to the numerical 1. Male, which was the second option I gave people, would be 2. So females are 1s, males are 2s. So looking down to question 3, right, highest level of school completed. It always goes in the order of options that I gave. So less than high school degree was option 1, high school degree was 2, some college was 3, et cetera, all the way up to option number 6, which was graduate degree. So if I go back and look at my question number 3, what's the highest level of school you've completed, on my spreadsheet, so let's clear this. Okay, so theoretically, graduate degree should be 6. So let me go back to my Excel spreadsheet. highest level of degree you've received is under D, right? So all of the 6s would be graduate degrees. It actually looks like none of my participants have graduate degrees, right? And that's kind of to be expected, right? Most people have lesser forms of education, right? So here, a 5 would correspond with bachelor degree, right? A 2 would be high school, so et cetera, right? I like to keep this as a reference point as I'm working with my data so I can frequently refer back to it. Okay, so back to our data, back to our spreadsheet. So what we need to do is we need to clean up this kind of top section that has lots of words all crammed into one space, right? Because I could extend it and have the full, question visible, but then it would create a really widespread data that would be hard to navigate. You'd be scrolling a lot, things like that. So instead of doing that, I want to simplify each column into a quick variable name. So what's your gender can just become gender. What's your age in years can just become age. Give everything a short, pithy little title. So highest level of completed degree could be education. Basically, you're just looking for a keyword that identifies this question, separates this question out from any other question, right? So which of the following categories describes your employment status, right? So I can call that employment. So go ahead and do this for all of your different columns. So notice, oops, misspelled. So for questions that were in the kind of standard question and answer format, the question itself shows up in column 1. Something happens when you use matrices. So remember, a matrix in SurveyMonkey is a question that's formatted like this, question number 7, where the prompt is please rate your level of agreement to the following statements, but the actual question is kind of over here, right? I eat at least 4 servings of vegetables, sweets, right? So what's going to happen in your Excel spreadsheet is instead of getting vegetables, fruit, sweets, whatever, you get, please rate your level of agreement for the following statements in this first line, right? Please rate your level of agreement for the following statements. Well, that's pretty useless, Jess. We don't need that, right? So go ahead and delete that. What we do care about is the actual individual prompt, which comes up in the second row, right? So here in the second row, we can see all of the little statements, right? I made an effort to limit my processed sugars, right? So we want to do the same thing here and give each column a name, but make sure it goes under the first row. And I'll show you in just a minute why that's really important. So eating at least 4 servings of vegetables can just become veggies. Servings of fruit can become fruit. Sweets. Right, so again, we're just looking for a keyword to set our columns apart from one another. Limiting processed sugars, so limit shug. Protein, I always spell that wrong, eating at least whole grains can become grains. Make an effort to minimize saturated fat, I can limit fat. So be careful because sometimes your variable names are very similar, right? So I just called one limit sugar and one limit fat. Make sure that you always kind of extend your columns the full length of your title so you don't accidentally mix something up because the beginning looks the same for both, okay? So, all right, so same, I'll take out education, employment, I'll extend out. Age doesn't need to be that wide anymore. Gender, right? So you can sort kind of the width of things so that you get what you need without too much information. Okay, total combined household earnings. So house dollar signs, right? Household income is this column. We have a race question. We'll call that race. What else? Oh, and then we need to do this other matrix. This was all about financial responsibility. So again, we can delete the larger, please rate your level of agreement to the statement. We don't need that. It's pretty useless. And instead, we're going to put a label in the first row. So strict budget can become budget. Saving money can become savings. Money. What's this next one? Fixed spending. So as you can see, this kind of is a little tedious, right? You have to go one by one, so I apologize that you have to watch me kind of do this. But this will be the process you go through when you clean out your data. So I think it's important for me to show you kind of the whole process. That way we don't accidentally skip over something. Let me purchase items I need. I pay bills on time, so timeliness. Additional payments towards debt becomes debt. Okay, so again, we want to extend things so that I can see my whole label. Nothing gets overlooked or confused. Okay, so now that every column has a label in the first row, all right, I have the information I need. I want to go ahead and delete this second row. So I can highlight the number 2 on the left-hand side. I can right-click it, and I can hit delete. That leaves me with one clean row that has all my labels in it. Now I want you to show you something else. So as you can see, there's these two kind of like blank columns here, one next to gender and one next to race. I'll show you the reason why that is. So when I asked the questions of gender and race, I gave people fixed options, right, male or female, but I also gave them this open-ended other option. And the other option had a write-in text box where people could self-identify or state their self-identified gender. So if they were to have typed something here, it would have shown up in this column here, right? So instead of 1, it would say either 0 or 3. I can't remember which. And then there'd be a typed written response here. So somebody could have said, gender queer. The words gender queer would have showed up in B2. So that's responded. So for the most of the time, you'll actually notice that these other options go left unused. So for instance, I'm scrolling through my data. Not a single person chose to self-identify their gender as something other than male or female. Any blank column, I want to get rid of. And I'll show you why. So delete that. Again with race. So did anyone self-identify their race? No, they didn't. They liked the options that I gave them. So I'm going to go ahead and also delete column G. Oopsies. Sorry, right click, delete. Okay, so now I'm left with a pretty clear set of data, right? I know what each column is. There's not a lot of extra space. It's all clearly organized. Okay. Oh, just some little side note. If you see that there's a blank response under a question, so for instance, participant number 35 didn't answer the question, fruit, how much fruit they consume. That's okay. Just leave it blank. It's kind of no big deal for now. Okay. All right. This is a good example of a cleaned up data set. The last step to finishing up your data set cleaning process is to convert your data into what's called a table. The reason for doing this, without converting your data to a table, you can't sort and filter your data without screwing it up. What do I mean by that? So let's take this employment section, right? Let's say that I wanted to group my responses in order of their employment status, right? So all of the zeros, which were employed working more than 40 hours a week, versus, so let's say I wanted to group employed all together versus employed working part-time versus non-employed looking for work, etc. If I do this now without converting my data to a table, I would go under data, I could hit sort, and I would select A through Z. But what this does is it sorts it by employment status, but if you notice, all this other data remained fixed. So for instance, the respondent's information to the other categories didn't sort along with it. I only sorted this independent column, and it mixed up the rest of my data, because now I don't know how this person actually responded to the rest of the questions, because who knows where they came from down here, right? So we don't want to do that, right? Undo. We want to convert our data into a table. So I go into the insert tab in Excel. I hit insert, and anywhere on your data set I can have selected, I hit table. What Excel does is it automatically looks for where you have information in your cells, in your rows and columns. And as you can see, it kind of drew a dotted line around my full data set. If I scroll down, it recognized where it started and stopped. Okay, make sure that this is correct. If by chance Excel didn't automatically get the right area or get the area correct, you can manually select, the space using the little select tool. But it did it right. The other thing I need to make sure is I've included my labels in the selection, so I want to keep the box ticked that my table has headers. I hit OK. If you'll notice now, what happened is it gives a little arrow next to each header, right? So now what I can do is I can sort based off of any variable. So again, we can sort household income. We can sort smallest to largest, but instead of just moving this column, it moves the corresponding rows. So now I know that this person's data is correct all across. So watch again, the whole data set moves, right? When I select one individual variable. Okay, so that converting your data into a table is the last step to quote unquote cleaning up your data. This is what I recommend from this point. Save this spreadsheet as what you want to call your clean slate data. So I'm going to go save as. I'm going to save this file as clean slate data. Why do I want to do this? I'm sure if you haven't figured out already, a lot of what we're doing here is manipulating the spreadsheet, right? We're moving things around, we're deleting columns, and we're going to be doing even more of this as we get into the manual coding section of things. So it's very easy as you're running a test, as you're manually coding, to accidentally make a mistake, to accidentally delete information that you actually needed, or to just get lost completely about what's where and where it should be. The reason I recommend saving an extra clean slate file is that if you make a mistake moving forward, instead of having to go back and try to figure out which response was supposed to be where and what number should have been in this column, you can kind of just exit out of your document and go back to your clean slate and start all over again. Okay, this is kind of like when shit hits the fan, at least you have somewhere to go back to rather than starting fresh, pulling it from SurveyMonkey and cleaning it all up again, because that's time consuming, right? As you can see by this recording, it's taken me a significant amount of time to get to this point. So save it from where you're at now, call it your clean slate data. I also recommend having a specific labeled folder for all of your data spreadsheets. Only put data in this folder, nothing else pertaining to your project. And that's because as you move on and as you do things, right, as you run a t-test, you can save it as an individual file and label it data with t-test or data with ANOVA. It's just a simple way to keep things organized and to know what you've done with your data set, versus not done. So always label it something clear. Don't get into the habit of clean data set version 1, clean data set version 2, version 3. Label it something that's identifiable so that you can refer back to it rather than going through and trying to figure out whether you did this one thing or didn't. Okay? Okay, so that is cleaning up data. Those are my recommendations about how to work with your Excel spreadsheet documents. Okay, so now we're going to move on to how to data sort. So let's say that you had a hypothesis. You wanted to test whether males versus females eat more vegetables, than the other group, right? So you need to be able to sort your data in a way that easily separates males versus females. So remember, for this survey, females are 1 and males are 2. So I recommend also making use of the sheet function. So here I just have a data sheet that's called sheet. I'm going to rename it and call it data. And then what I'm going to do is I'm going to copy this data set. So I'm going to hit move or copy. I'm going to check the create a copy box and duplicate it so that I have data and then I have data 2. Under data 2, I'm going to rename this as data by gender. You'll notice that in many of my assignments, I utilized this function, right, where there are multiple pages. It includes the same information, the same data, just organized in a different way. I find it simpler to kind of use these tabs. Okay, so our data is here, and then data by gender, this is the sheet where we're going to sort things. So under gender, I can go ahead, I can sort smallest to largest. What it does is it puts all the ones together with their corresponding responses in the top, and then it puts all the males in the bottom, number 2s with all the corresponding responses. I recommend once you sort it to then insert some extra rows between the 1s and the 2s so that you have clearly defined groups. So I like to do this. I insert a few rows, maybe even I make one row a different color. Which by the way, you can change your table style if you don't like the way it looks. But so maybe I put X's in this whole row, whatever. Because sometimes if you're all the way over here and you're looking at the variables on the right-hand side, you can't necessarily quickly refer to, am I still in the 1s or am I in the 2s for gender, right? So having this visual separation makes sure that you're selecting the right group of people. Okay, so now you have a clean set of data that's female, data that's male here. And right when you're doing your t-test, let's say that you're running, what was my example? Fruit consumption, right? When I'm doing my t-test, my first group that I'm selecting is, female fruit responses to here, right? That would be my first t-test selection. My second t-test selection would be down here, male fruit selection, right? And then I can also, if I wanted to add in some like by group information, right? So let's say I wanted to compare the veggie score of females versus male, right? In this space, I can look at some descriptive statistics, and I can run some averages between groups. So, right, I can look at the average of veggies for females. Close that up. Oh, I can do that, right? And then same thing, I can add some columns down here so that I have room to do the same thing, right? Okay, so that's why I like to use visual spacing between the groups. Okay, so now you have grouping, right? You can do that for any variable. You could do gender, you could do age by number, you can do it on some of your other categorical, variables. So if I wanted to separate by, instead of gender, let's say education, right? So I go back to my data, duplicate this, right? So move or copy. I want to create a copy. I rename data 2 to data by, what do we say, employment status? Data by education, right? And then on this tab, I can sort education, smallest to largest, my 1s and 2s break here. I can insert a few spaces here, so that's group 1, right? I can insert here, right? So then I can create a data set that has all of the high school GED versus high school diploma versus some college, etc. So I can do that for as many grouping options as I need. Education, gender, race, household income, any sort of categorical variable that needs to be grouped. Okay, so that's that. For going back to my main data, I'm going to show you kind of 3 different skills that all fall under what's called manual coding. So manual coding is anything that you as a human need to do by hand in a tedious manner because Excel's not smart enough to do it. There are some downfalls to Excel compared to SPSS, and some of these things in SPSS are easier, but we're working with Excel, so this is what we got, okay? So the first aspect of manual coding is inverse coding. What do I mean by inverse coding? All right, so let's take a look at our survey. I asked all of my respondents to answer a series of questions related to their nutrition, right? So I asked 1, 2, 3, 4, 5, 6, 7 different questions, right? I asked them to comment on how often they do the following: eating vegetables, eating fruits, limiting processed sugars, right? All of these questions, in theory, right, the more often they do it, produces a higher nutrition score, right? The more vegetables they eat, the better. The more fruit they eat, the better. The more protein they eat, the better, right? The more they make an effort to minimize saturated fat, the better. Except sometimes in our question sets, they'll throw these kind of backwards phrased questions. So for instance, I eat at least 2 servings of sweets per day. Well, if people are eating more than 2 servings of sweets per day, that's actually not helping their nutrition status. It's hurting their nutrition status, right? If somebody says, I have 7 desserts a day, that doesn't mean that they're eating in a nutritious way. It's actually a pretty unhealthy habit, right? So this is where I need to inversely code the responses to this question, right? Because it's not that more often makes them more nutritious, it's that less often makes them more nutritious. So I need to tell Excel that here a score of 5 is actually bad and a score of 1 is good. Like I said, unfortunately, Excel doesn't know how to do this in an efficient manner, so I need to go and do it by hand. So this is what we're going to do. So let's see, we're working with this data set. So sweets is the item that I need to recode. I'm going to insert a new column next to sweets. They call it column 1. I need to name it something that's effective, like real sweets, right? And then I'll call this don't use this sweets, right? Because these are the answers that aren't correct or not properly coded, and we're going to put the properly coded ones in this column, right? I want to use these, not these. So what I need to do, first step is I need to figure out how many different options were in my question. Oops, wrong spot. So here I used a 5-point scale from 1 to 5. So I have 5 options. What I'm going to do is I'm going to inverse the numbers. So for this question, if they filled in this bubble, it should really be treated as a 1. This would be a 2. Oopsies, not very good at this. This would be a 3. This would be a 4. And this would be a 5. So in other words, I'm flipping the scale, right? Because I want it so that if they're eating more sweets per day, that they have a lower nutrition score, or vice versa. If they're not eating as many sweets, they have a higher nutrition score. So what I need to do is I need to go into the column, the not good column, the original sweets column, and I need to take the original score and exchange it with the real score. So every 5 becomes a 1, every 4 becomes a 2, every 3 stays a 3, every 2 becomes a 4, every 1 becomes a 5. I recommend keeping a piece of paper with these little rules on them right next to you so that you can refer to it pretty quickly. So this is what I start doing. Oops, so clear all my drawings. Okay, so this is what I start doing. I go into my data set, right? So every 1 becomes a 5. So I can go through and I can manually put all my 5s in. Okay? Da-da-da, make that a 5. Make that a 5. Make that a 5. Okay? I recommend kind of doing it this way where you're searching for 1s rather than doing it individually, because then you're more prone to error. Okay, every 2 becomes a 4. I'm looking for 2s. I'm still looking for 2s. Okay, 3s remain a 3, so we can put 3s there. there's another 3. All right, so we're doing this. A 4 becomes a 2. 2, 2, 2, 2, 2. Oh, I missed the 3. 4's become 2s. 4 becomes a 2. So as you can see, this is a little tedious. Like I said, you just got to do it. Theoretically, we should left be all the 5s, which then become a 1. Double check. Oopsies. See what I mean? I just accidentally edited the wrong column. In this case, I can quickly just use the undo function to fix that. But it's important to be careful here. 5s become a 1. 5s become a 1. 5s become a 1. Okay. So I have just successfully inversely coded my sweets variable. I'm just going to change this actually to like a symbol that I'm going to ignore. Oh, I can't do that. Don't use. Okay. And I'm going to change this to just sweets. So this is what, oh man, what is it doing? Jeepers creepers. And this actually doesn't matter because I'm not using it anyway. But it was a 2. Okay, so now, so that's how you inversely code. For this survey, I need to inversely code the sweets question because that was backwards. And then I had another question that needs to be inversely coded on my financial responsibility. And you might be able to pick it out here, right? So I can keep myself to a strict budget. I make an effort to save money for emergencies. I find myself without funds to pay my bills. I have a fixed spending limit per month. I purchase only items I need. I pay my bills on time, and I make additional payments towards my debts. All of these, except for one, if you rate it highly, means that you're more financially responsible, except for one of them, right? If I find myself without funds to pay my bills, this actually should be that if you know, rate that this, you rarely disagree or strongly disagree with the statement that you have a better financial responsibility, right? Because if people often don't have money to pay their bills, that means they're not financially responsible. So I need to inversely code this item as well. Same thing here, except notice instead of a 5-point scale, I have a 7-point scale. So again, I would just kind of inverse it. So for here, a 7 becomes a 1. Then go backwards, 2, 3, 4. So you'll see your neutral option will always remain neutral if you have an odd number of responses. 1s become 7s, 2s become 6, etc., etc. So I'm not going to, you know, put you through the painstaking process of me doing this again on my spreadsheet, but that's how you would do it for a different scale. Okay. All right. So that's how you inversely code. Oops. How do we get rid of my annotations? Clear all drawings. There we go. Okay. That's how you inversely code a variable. The next skill we need to discuss is what's called aggregating variables. So, like I mentioned, I wanted to know about people's nutritional scores, and in order to kind of get a sense of their overall nutrition, I asked them, I believe, 6 or 7 different questions pertaining to their nutritional habits, right? So variables G through N, with the exception of my don't use variable here, all pertain to nutrition. And the idea is that if I combine the answers of all of these questions, I get one big nutritional score. So I actually, so I need to make a column for that nutritional score to go in. So I created a column here, O. I'm going to call it nutrition. And in order to produce my overall nutrition score, I'm going to go ahead and use my adding function from Excel, right? My sum function. So I want the score from each question. So veggie, fruit, my new sweet score, we're not using this one, limiting sugar, protein, grains, and limiting fats. Okay, So Excel is smart enough to know that if I want the sum of these columns in the first row, I also want them in the rest. So as you can see, Excel auto-generated all of my sum scores for me, right? So each one of these scores, um, hmm, is right. So is a combination of G, H, I, K, L, M, and N. Skipping J because we don't want that, right? So now we have a total nutrition score, right? A lot of you have these matrices where you want a total score, right? So you're asking a whole bunch of questions about stress. You want an overall stress score. You're asking a whole bunch of questions about mental health. You want an overall mental health score. This is how you do that, how you generate the overall theoretical variable score for nutrition. So I would also do that for financial responsibility after I inversely coded my backwards question about being without money. Okay. So then whenever you're running a statistical test on somebody's nutrition score, you can really do away, you don't have to pay attention to any of these variables. You're really only focused on your aggregate, your sum variable of overall nutrition. Okay, so that's what I'm talking about when I refer to an aggregate variable. The last thing that you need to know about manual coding is what's called using dummy variables. Now, this only pertains to the group that's using a regressional analysis. And I'll tell you why. So Microsoft Excel treats everything as a raw number on a decimal or ratio scale. It doesn't know which variables were ratios versus categorical versus intervals. So we have to kind of trick it into doing away with the level of measurement each variable was and just giving it a very simple binary code to follow in terms of if a respondent fell into one category versus another. That's a lot of words. Let me show you what I mean. So let's say that we're working with categorical variable. Let's say unemployment. It's very interesting here, by the way, that for some reason they gave categorical responses as 0 rather than just 1 through 5. But anyway, so Excel doesn't realize that this is a categorical variable and that 0 isn't actually numeric 0 versus 4 isn't actually numeric 4. So if I tried to divide or multiply these answers, Excel would do it, right? Because it thinks they're just numbers. When in reality, we can't multiply or divide different answers to how you're employed, right? That just doesn't make sense. It's a category. You're either in one category or you're not, right? So we need to create employment dummy variables. So this is what I mean. Oh, and we're going to the left, because why not? Okay. So let's go back to what my employment options were. So here, 0 is my first option. 0 is employed full-time. Okay. So I'm going to create a column for each of my options. So employ full. And in the beginning of the column, I'm going to put the corresponding numeric value. So 0 is employed full-time. 1 is employ, and what was it? I believe part-time. Let's double check. Employed part-time. So 1 employee part. I'm going to go ahead and do this for each one of the options that was provided under employment. So there are 6 options. So I need to make 6 new columns, and I'm going to call them each employed full, employed part, employed no work, employed work, employed no work, employed retired, or employed disabled. And then what I need to do is I need to go through and basically put a tally in the column that the answer corresponds to. So this is a 0. I need to tally or put a 1 in the 0 column. because it was a 0. If it's not falling in the category, I put a 1. So, or sorry, a 0 if this doesn't apply, right? So basically it's 0 for a no or 1 for a yes. So are they 0 employed full-time? Yes, I put a 1. Okay. Are they, so for the next response is a 1 employed part-time. So I put a yes or a 1 in the employed part-time category. For everything, for all the other options, I put a 0. Again, this is a 1, so I put a yes in the 1 employed column. These are zeros. I put yes in the employed full-time column. This is a 3, so this is what I mean. You have to have enough columns for as many options. So here I would go to the number 3 employed not working column, and I'd put the 1 there. I'd put zeros in all the other options. Basically what I'm doing is instead of one variable that has lots of options, I'm giving lots of variables with either a yes or a no option. This will tell Excel either they fall into this category or they don't. And it'll help us process a regression in a way that makes sense. So the regression group, and I can help you further if you need help, you'll need to do this for every categorical variable you have, which totally stinks, right? Because I know you have multiple categorical variables like major and their race and all sorts of things, right? So you're going to have to do a lot of this dummy coding, is what we call it, dummy variable coding. So you're going to end up with a pretty wide spreadsheet. Make sure that you kind of keep them labeled consistently so that you know what they refer to. And I also recommend keeping the original column just as a reference too, so that you don't lose track of what the original response was as you're dummy coding. If you need more guidance on this, you can go ahead and look up regression linear analysis dummy coding in YouTube, and they'll show you this concept further. But basically, you're just going to go down the line, and depending on which option they selected, you're going to put a 1 in that column, and then put zeros for the rest. Okay, so you're converting it to binary. And like I said, you have to do that for every categorical variable that you're going to be putting into your regressional analysis. So for here, I can keep gender because there's only 2 options, ones and twos. But for any categorical variable that has more than 2 options, right, it's not binary, you need to convert it. So here I would need to convert education, and I need to put, 6 different columns. Education 1 being didn't complete the high school, education 2 is high school, education 3 as being some college but no degree, education 4 being bachelor's degree, etc., right? You do that for education. I would need to do that for household income, because here, instead of just an insert a number, it was a category select an option or a range. I need to do that for race as well. So go ahead and do that. Okay, once you have your data cleaned up and you've completed all of your inverse coding, you've created any aggregate variables, and you've done any dummy variable coding for regression, you are officially all set and your data set for running statistical tests. And you guys should know how to do this, right? That's what we've been practicing in Excel the whole course. How to run a t-test, how to run an ANOVA, right? You're just going to use your handy-dandy data analysis toolpath to run your information. Also, don't forget, we can use demographic information, right? For any of these columns, right, for nutrition, for my financial responsibility, for my age, I can run mean, standard deviation, mode, right, and get all of that demographic, or sorry, descriptive statistic information. That's going to be really helpful for kind of looking at, hey, overall, who responded, how old were they, what racial identity did they have, right? Did mostly individuals identifying as Caucasian respond, or was it primarily African Americans, right? Run your modes and your frequencies for all of your variables, and then for any ratio or interval variable, you can run mean, median, mode, standard deviation, variance, okay? So that's that. Take a look at the rest of the assignment, because part of this week's assignment is going to be figuring out with your group which one of these steps, right, you'll need to take once you are done collecting responses. Will you need to inverse code any items? If so, which ones are they? Will you need to make any aggregate variables? If so, which questions will they include? Do you need to do dummy variables for which categorical responses, etc.? You're going to create a plan, right? A data analysis plan that involves how to clean up your data, what sort of manual coding you'll need to do, and then after that, what tests you're going to run and which variables you'll use in order to do that. Okay, so take a look at that assignment. You'll work with that as a group this week. Otherwise, come to office hours if you have any questions. All right, guys, thanks so much for watching. Hope you have an awesome week.